Hi folks, I'm Giorgio Comai, researcher and data analyst at OBC Transeuropa, and I contribute to the work of EDJNet, the European Data Journalism Network. Today, I'd like to talk about data distributed as geographic grids. So basically, this means just imagine a bunch of squares overlaid on a map. And these are usually generated through satellite imageries, and machine learning techniques is then used to analyze them. And the data set generated in this way usually cover issues such as the environment, the climate, and the natural world more in general. But they can also include data on other aspects. And the comprehensiveness and detail of such data is great, but presenting data distributed as a grid is not so easy. It is actually quite a challenge for data journalists. Gridded data have also some peculiarities that may generate some misunderstandings. In this video, I will give you a walkthrough of some of the difficulties inherent in working with gridded data based on a dataset on change of temperatures that was at the base of a recent article and interactive interface published by EDJNet. So, let's dive in. Let's start from one of the areas that are more difficult to be described with gridded data. We are here in the middle of the Alps. And this is how a grid looks like. The side of each square, in this case, is 5.5 kilometers. These data refer to the difference between the average temperature recorded in the 1960s and the 2010s. As you see, in some cases there is very substantial discrepancy between neighboring cells, largely because some refer to high mountainous areas while others refer to the valleys between them. Due to the complexity of the terrain, however, in some instances even relatively small grid cells of 5.5 kilometers, such as the one used for this analysis, may include both high peaks and valleys. The challenge we face as data journalists is how to report this data in a way that makes sense to the wider public. So, given the high resolution of the grid, in this case, we decided to use municipalities as a point of reference. You now see administrative boundaries. Unfortunately, there is no correspondence with the gridded data we have. Besides, high in the mountains, administrative boundaries of a given municipality include cells with very different data. Which ones do we present? Let's look, for example, at this particularly complex case, the municipality of Martel in South Tyrol. If we use the center of the municipality as a point of reference, or just calculated the average of all cells included in this municipality, we'd have a high figure, as the municipality includes large mountainous areas. Instead, we decided to calculate the population-weighted center of each administrative unit. What does this mean? We take another dataset, published by Eurostat, that estimates how many people live in each square kilometer of the continent. The numbers you see are an estimate of how many people live in each of those squares. So we do some math and calculate which is the center of a given municipality based on where people actually live, and there we go. We report the figure for the corresponding cell. This is of course not perfect, as in some cases this still leads to two neighboring municipalities showing rather different results. But in the overwhelming majority of cases, the data are meaningful. Let's move on to Flatlands to check out how this all plays out there. As you see, again, there is no correspondence between administrative boundaries and grid cells. But this is not an issue, as data change smoothly. In flatlands, hilled areas, big urban centers, in all of these places we do not have the kind of problems detailed in the mountains. However, there is another type of terrain that poses some challenges to gridded data. Let's move on to the seaside. As you see, the average temperature has increased more sharply on the sea than on land. In cases when the center of a given municipality is within a couple kilometers of the coast, the final figure depends on whether that specific grid cell included a lot of sea or only land. So again, comparing neighboring municipalities is not very useful, as the difference between them probably depends on the way the data is generated rather than on actual differences on the ground. The point of publishing this data, however, is not to enable direct comparison between neighboring villages. Indeed, when talking about a global phenomenon such as global warming, such comparisons rarely make sense. Finally, as a matter of fact, in many cases, local data are not a good indicator of how much a place is feeling the impact of global warming. This area, for example, shows some of the lowest temperature increases in Italy. But when we look closer, I suppose we all understand that this does not mean Venezia will be safe from the consequences of global warming.